the idea of today is difference quotient, okay, which is basically a fancy way of saying we're finding slope, actually. Okay, so before we read all of this stuff, let's just look at this quick picture here. Okay, I've got 2 points. I've got the point P and I've got the point Q. Okay, ignore all of this notation for a second and pretend that P was just the point X comma Y. Okay, actually let's label it X1, Y1, X1, Y1. And our Q, let's just say it was X2, Y2. Okay. If I have this blue curve, okay, this is a blue curve that we're given. This is our function f of x. We are trying to find the slope between the 2 points on this curve. So you call that a secant line. A secant line goes through a curve at 2 points, okay? So if I wanted to find the slope, our equation for slope between these 2 points, well, first of all, what is our letter that we normally use for slope? M. Okay, a lot of you remember rise over run, okay, but if I was writing this out in terms of the notation that I just gave you, that would be y2 minus y1 all divided by what? X2 minus x1, okay? Now, the order does not matter as long as you subtract the same from on top and on bottom. Like if I start with y2 on top, I have to start with x2 on the bottom. But if I start with y1, I can start with x1 on the bottom, okay? Now, in terms of the difference quotient, okay, this is where that x plus h part comes in and where it gets a little bit tricky for students to understand, is all we are doing is we are taking this point of x comma f of x, which is really x comma y, right? But just function notation, okay? And I am now going to add, it says, let's say the next point is h units over. So if the next point is h units over from x, I would label that as x plus h, right? It's just x plus h units. Say it was 5 units, it'd be x plus 5, right? My y value, same thing. I would plug in our x value of x plus h to figure out what my y value is as an output. Okay, so this is the exact same thing as what we just wrote, except for the notation now looks like this. It's going to be my y2 value, which is f of x plus h, minus my y1 value, which is f of x. Ran out of space there. And then that's all being divided by my x2, which was x plus h, minus my x1, which is x. Okay, do we see where I got all of those things from the points that we were given? Okay, now if I simplified this, as you see over here, some of you probably already looked at it, okay, this answer, f of x plus h minus f of x divided by h, is the exact same thing because what happens to the denominator there? Yeah, those x's are going to go away, right? So I'm just left with h in the denominator. So this is my difference quotient. We are finding what does that equal.
So we just plug something.
Yeah, so we're going to plug in our x plus h, and we're going to get a gross thing like we did on the board here, but then we're going to be able to simplify it, okay? So again, this whole thing is called our difference quotient, okay? Which is super important in calculus. This is like the first thing that we do in calculus next year. So this graph, again, the PQ line is a secant line, and here's where the calculus part comes into play. So it says as x approaches 0, the slope of my secant line approaches the slope of the line tangent to the curve at P. That was a lot of words. So let me go look at this picture here, okay? Basically what is happening is this h value, I want this to basically get to 0, okay? Which means if I get closer and closer on my curve, and I would draw my secant lines between all of these, and I get closer and closer, my slope is getting closer and closer to what we call the tangent at the point. This point right here, this line is tangent to, so we can figure out the slope of this line here in green if h is 0. So basically, if we have 2 points that are really, really close to each other, okay, we can figure out what that slope is. So we're actually kind of taking a derivative. It's kind of cool. You guys just aren't aware of it, but you guys are actually doing it, okay? So let's see here. It says, important applications of this are developed in calculus where the concepts of limits and derivatives are investigated. Okay, so I'm going to show you how to solve these in our pre-calc method, and then I'm going to show you what it means in terms of a graph, okay, which might be a little bit too complex for some of us. That's okay, because this is, again, this is the pre-calculus to calculus, right? So it gives you a little bit of an intro to it, but you don't have to know how to do it, okay? So let's look at example number 2 first, and then we will come back and try out example 1. Okay, so I've got a function g of x. It equals 4x plus 3. Now, our difference quotient says I'm going to take g of x plus h, and I'm going to subtract g of x. And then we're going to divide all of that by what? By h. Okay, so this right here is our formula for our difference quotient. So the first few questions on your homework are split up, so that way it's kind of a step-by-step. So let's go ahead and do it like that. If I want to find what g of x plus h is, that means I'm going to plug in x plus h where I see x, right? So this becomes 4 times x plus h plus 3. Okay, let's simplify that. If I distribute the 4, I get 4x plus 4h plus 3. That is just my function evaluated at x plus h. So technically this right here is my y value on my curve if my x value is x plus h. Okay? Now that would be like part A on your first 2 questions on your homework. Part B is going to ask you, okay, well, what is g of x plus h minus g of x? Okay, so we can evaluate that by plugging this stuff in. So I know that g of x plus h is this here in black highlighted. Okay, so I've got 4x plus 4h plus 3, and I am subtracting g of x. What does g of x equal? 4x plus 3, right? So I'm subtracting 4x plus 3, and this is where people make mistakes because I'm subtracting the whole function of 4x plus 3. So what do I need around the 4x plus 3? Parentheses, okay? I have to have parentheses around that function that I am subtracting. So now from here, I can go ahead and simplify this, right? This now becomes 4x plus 4h plus 3. And then I distribute this negative. It becomes negative times 4x, which is negative 4x. Distribute this negative to the 3, I get minus 12. Now, can I simplify some stuff here? Oh, wait, sorry, it should be minus 3, not minus 12. I look up and you guys were all looking at me like I'm crazy. Okay, so now what goes away? What cancels out? Yeah, the 4x's and the 3's go away, right? So all of those are now gone. And I'm left with just 4h. Okay, so remember this 4h part is actually just the top of my difference quotient, right? That's all I just found. The g of x plus h minus g of x. Now the quotient, or the difference quotient, okay, says that I still need to divide by h. So this is technically part C on your first few questions on your homework. It says, okay, well now do the whole thing. If I simplify this, what is 4h divided by h going to give me? 4. Okay, so our answer is 4 for the difference quotient of this function, 4x plus 3. Okay, now the kind of calculus part behind it, this part you don't super need to know, but just conceptually, like what is this doing? This is a function, okay, that if I graphed 4x plus 3, I would be like up here at 3, and then I would have a slope of 4, right? So my graph would look something like this. What we just found, 4, tells me the slope, and specifically this is a line. So what is the slope of my line? 4. The slope of my line, slope of 4x plus 3 is just 4, right? So this is a line, so it's easy for us to kind of visualize, okay, well, yeah, at any point on this line, you guys agree that the slope's going to be 4, right? Perfect. Okay, now the one that we're going to do next, this first example is 2x squared minus 3x. Is that a line? No. Okay, so it is not going, it's still going to give us a slope, but it's going to give us more specifically a rate of change with an x in it. Okay, so we'll do the difference quotient first, and then I'll show you guys what it looks like on an actual graph. Okay, so you guys just did calculus.
Yeah.
Smart people. Okay, you should feel so smart. Okay, so I've got now f of x equals 2x squared minus 3x. Okay, so again, let's just kind of break it down into our 3 steps. Our function that we are actually solving is f of x plus h minus f of x, and that is all divided by h. Okay, you can do this all in one step if you would like to on your quiz, on your test. Actually, it's not going to be on a quiz, it's just going to be on your test. Or you can kind of break it down step by step if you would like your homework does for the first few. So if I wanted to evaluate f of x plus h, that means I want to plug in x plus h anytime I see x. So I've got 2 times x plus h squared minus 3 times x plus h. Okay, so similar to the one that we did on the board, we need to simplify this. Okay? I need to go ahead and FOIL out this x plus h squared piece. Okay, that's technically the same as x plus h times x plus h. I do not want anyone to leave their answer as x squared plus h squared. That is not what you get when you distribute that, right? So if I distribute my x plus h times x plus h, I should get 2 times x squared plus how many hx's? 2 hx's plus how many h's? Squared, right? Then I can distribute that negative 3. Distribute that negative 3 to both terms, and I get minus 3x minus 3h. And we can still do one more step for this. What do I need to do next? Distribute the 2. So I get 2x squared plus 4hx plus 2h squared minus 3x minus 3h. So that was just our f of x plus h term, right? That is just this piece right here in terms of my difference quotient. Now, your step B on your homework for the first few will say, okay, well, now that we know f of x plus h, let's take f of x plus h and let's subtract your f of x function. Okay, which really you're subtracting your 2 y values, right? So I'm going to rewrite my whole f of x plus h term. And now I'm going to subtract my entire quantity of f of x. What is my f of x quantity?
2x squared.
Yeah, 2x squared minus 3x. It's right up there. So times 2x squared minus 3x. Okay, the most important thing here is to not forget your parentheses around your second term there, and we have to subtract the entire thing. So now I need to do what with that subtraction sign? I need to distribute it, right? So I need to distribute here to get my answer of 2x squared plus 4xh, 2h squared minus 3x minus 3h, and none of those things can be combined. But then I get negative 2x squared and positive 3x. So some things can go away, right? My 2x squareds go away. What else goes away? My 3x's go away. Okay, so what we're left over with here, on the top I've got 4hx plus 2h squared minus 3h. And I need to divide all of that by h. So this is kind of your like step C on your homework for the first few questions. Kind of breaks it down. So what could I do from here? Can I simplify this anymore? Yeah, what could I take out at the top? An h. So let's take an h out. If I take an h out, I'm left with 4x, excuse me, plus 2h minus 3. That's all divided by h. So now those h's go away, and your final answer is 4x plus 2h minus 3. Okay, and that is your answer. Now, that's kind of as far as pre-calc takes it. However, I will give you a bonus point if you take it one step further and actually evaluate it, do kind of the calculus portion, okay? All you do at that case is you are taking, and we are looking, if you go back to this piece up here, okay, it says we're looking at when h is approaching 0. So let's say h is getting really, really close to 0. Let's just call it 0. If I plug in h is 0, if h is approaching 0, h approaches 0, what would this expression simplify to? 4x minus 3. So once I actually get rid of that, 4x minus 3, that is the calculus piece that you just did. That is technically finding the rate of change at a specific point. Okay? Well, it gives us the rate of change for the entire function. Okay? Now, because this one was not a line, obviously looking at this function here, like, how do we know that this is what our slope is, right? Doing this method of the difference quotient and kind of looking at limits, you guys basically just took a limit, allows us to figure out the derivative at that certain point, okay? So again, either answer is fine. If you give me this calculus answer, I will give you a half point extra credit on your test, okay? If you leave it as this answer, you'll get just, the regular points, okay? Now, the one thing I want you to be careful about is you cannot plug in h is 0 until the very end. Because if I plug in 0 here, I'm going to end up with 0 on top and 0 on bottom, okay? In calculus, we call that an indeterminate form. We can't have 0 over 0. So we have to simplify it first, get rid of those h's, and then I can plug in 0. Does that kind of make sense? A little bit? You guys are so smart. Okay, so I'm going to show you quick the graph. And again, if this is too high level for some of you, that's okay. The basics for pre-calc that you need to do is be able to evaluate this function right here, f of x plus h minus f of x over h, and simplify it down, okay?